Yes, sir. The live stream started. So I shall begin the session, sir.
Yes, ma'am. Yes, ma'am.
Yes. A very warm welcome to all the participants, faculty members, students, and distinguished guests joining us today. On behalf of the Department of Computer Science Engineering, with specialization in cybersecurity from RMK College of Engineering and Technology, I'm delighted to welcome you all to the Generic Talk Series number 30. Today's session promises to be both insightful and inspiring as we explore the topic modern data engineering, trends, technologies, and principles. In today's data driven world, data engineering forms the backbone of every successful digital transformation initiative. It empowers organizations to collect, process, and analyze vast amount of data, enabling informed decision making and innovation. We are honored to have with us Mr. Srikanth Gorripati, Senior Data Engineer at Mutual of Enumclaw, Fortville, Indiana, USA. Before we begin, I would like to remind everyone that the session is being live streamed on RMKCET YouTube channel. We encourage our online audience to actively participate and make the most of this wonderful learning opportunity. Now, I would like to call upon Dr. S. M. Shankar, the head of the Department of CSE Cybersecurity, to deliver the welcome address. Please, sir.
Thank you, ma'am. Good morning, everyone. It gives me immense pleasure to welcome you all to the Generic Talk Series 30, organized by RMK College of Engineering and Technology. At the outset, I extend a warm welcome to our distinguished guest speaker, Mr. Srikanth Gorripati, Senior Data Engineer at Mutual of Enclub, US, who has graciously accepted our invitation to deliver a talk on modern data engineering trends, technologies, and practices. We are truly honored to have you with us, sir, today. Your vast experience and expertise in the field of data engineering will certainly provide our faculty members and students with in-depth understanding into the latest trends, frameworks, and best practices shaping the modern data landscape. I also extend my heartfelt welcome to our respected Principal Dr. N. Suresh Kumar, Dean of Academics Dr. Shivaram, Dean of Research Dr. K. Ramar, and all the heads of the departments, faculty members, parents, and students who have joined us through our RMK CET YouTube channel this Sunday morning. The Generic Talk series has always been a platform to bridge the gap between industry and academia. And the today's session is another step toward enriching our collective knowledge and inspiring innovation among our learners. Once again, I extend a warm welcome to all of you and wish this session a great success. Thank you.
Uh, Thank you so much, Uday Shankar sir and ma'am as well. Um, I definitely feel like this as a privilege and then a great honor to share all the knowledge that I have being working as a senior data engineer in at various large-scale insurance industries in United States for the last 8 years. Uh, so I sincerely thank Uday sir for giving such a wonderful opportunity. I think I don't have to give much more
Uh,
introduction about.
I would like to introduce our guest for the today's session. It's my pleasure to introduce our distinguished guest, Mr. Srikanth Gorripati, Senior Data Engineer, Mutual of Enumclaw, Fortville, Indiana, United States. Mr. Srikanth brings with him a wealth of experience and expertise in the field of data engineering and large-scale data processing. He is well versed in Hadoop and Apache Spark, leading the charge in designing and building robust ETL pipelines that ensure efficient data integration and transformation. He has hands on experience in implementing cloud data solutions using platforms like Snowflake and Databricks and is adept in real time data streaming in Kafka. His technical proficiency extends to Cosmos DB and Cassandra for NoSQL data management and cloud services such as Azure and AWS. In addition to his engineering practice, Mr. Srikanth has strong programming skills spanning Java, Scala, Python, and PySpark, along with analytical libraries such as NumPy, Pandas. He has collaborated with data science teams leveraging REST APIs, CDPs, and Elasticsearch to deliver high performance data solutions. Professionally, Mr. Srikanth has had an impressive career journey. He began his career with Tata Consultancy Services, where he worked as senior system engineer for nearly 8 years. He then joined GIECO, a leading US based insurance firm, where he served as a senior data engineer for 5 years. Currently, he is associated with Mutual of Enumclaw, continuing his impactful work in the data engineering domain. Much of his professional experience revolves around banking and insurance sectors, where he has successfully built data driven solutions that enhance decision making and operational efficiency. Beyond his technical depth, Mr. Srikanth is admired for his analytical thinking, problem solving ability, and commitment to excellence. His dedication to achieving demanding objectives with precision makes him a true role model for aspiring engineers. We are indeed privileged to have him with us today to share his valuable insights and experiences. Please join me in giving a warm welcome to Mr. Srikanth Gorripati, sir.
Uh, Thank you so much. Am I audible?
Yes, sir.
Okay. Thank you so much for the intro. Definitely, it's a very great opportunity for me to share all the knowledge and insights that I have being working as a senior data engineer at various large-scale insurance industries in USA. I'll definitely try to share all my experience in this forum and then try to take all the questions from you guys. Without any further delay, let's start the session. Can you able to see my screen?
Yes, sir. Yes, sir.
Okay, nice. So what are we going to talk today? So we are going to focus on various concepts of data engineering, why it is important to the industry. So you guys might be theoretically enriched in the concepts of data warehouse, data engineering and all, like in your academic careers, but what exactly happens inside the industry? What kind of applications are the projects that which we work on? So that's pretty much the crucial items that which I'm going to touch in this corresponding session. So I'll be talking more about the legacy landscape, like of how the traditional ETL patterns are used to be, and how we have designed the modern data pipelines. How was our journey of transforming from the legacy traditional ETL pipelines to the modern ETL, building modern ETL pipelines? And then what skills does really matters, like in order to set up our particular career, what are the exact skills that you guys need to be upskilling yourself? And I will also try to bring up some of my projects that which I worked in the past, like some of the pipeline designs that which we have designed, built, and then also maintained at our previous workplace and the current workplace as well. So feel free to interrupt me at any point of time during this session. So I'll be talking for the next 45 minutes. And then, like, in case if you guys have any questions, you can interrupt me and ask questions at any point of time. Okay. What exactly data engineering is all about? So we know, like, it's data engineering is a process of designing, building, and also maintaining the data systems, the systems that actually collect the data from various sources. We will clean and cleanse the data, we will process, and also will transform the data based on certain business rules. And finally, we will store that particular data into the target systems to enable the analytics and also the reporting purposes. So that's majorly what data engineering is all about. You extract, you transform, and you load into the system and then use that particular data for various business use cases, right? That's majorly what we do as data engineers. And why is it so important? It's important because data is the key. For any organization to get succeeded, without data they cannot survive. Like, that's the key. And how we get data from multiple sources, but we need to curate that. We need to clean that, and then curate it according to the business requirements, and then make sure like that particular data is much more insightful, handy enough, and also like all the strategic business decisions can be taken based out of that clean data, right? All various use cases that I can talk about further down the line in this presentation, how this data is going to be useful. As a data engineer, like our main objective is to design the systems such a way that like they are scalable. Like we shouldn't have any limitations on the volume of the data that which we deal with. So at our previous organization, we used to deal with petabytes of data, like all at one of our previous client, like who is an insurance company. We have a lot of insurance policies. We get the quotes information, claims information, all the policies data and all. The amount of data, the volume used to be in petabytes, and that in order to clean or like transform or apply any logic on the particular data, it's not easy. It takes a lot of effort. You have to design the systems in such a way that your solution will work for the existing data volume, and also like even if it scales down the line, it needs to address all the challenges that comes with volume. And the second major challenge that which we have is to maintain the data quality. Right, the data is unstructured. Some of the sources from where we get the data is either unstructured or semi-structured. Like you can't expect the data to be much more formatted. Let's say, for example, like you give a registration form uh, to an end user. Okay, who wants to who wants to apply for an insurance policy for his car with our company. Hey, he has a Swift car, and then like he came to us. Hey, I would like to insure my car. Can I be your customer? And then he fill his form. While filling his form, like he can misspell his name. He can misspell his address. Like the data is not clear, or it's not quality. But the data that whatever that he filled in the form, like in the court application system, that particular data will be stored in our court systems. But that data cannot be used for our analytics purposes. Like for example, if I have a use case, like I have a use case like identify all the customers who has uh, who actually got quote from us last week, but those quotes are not converted into policies. So like I have 10 customers who took the quote from me. Like, each policy quote is $500 per month or $600 per month. For some reason, the customer is not happy with the quote, and he moved on to a different competitor. But, we need to analyze, like, as a business, we need to analyze which customers actually couldn't able to, convert those quotes into policies. On a daily basis, we will analyze those unsold quotes, and then we will get back to those customers and try to get their feedback to resell those policies to them. So that's the way that how we will try to improve the business. That's one of the way that how we will try to reach out to our customers. So considering this particular example, like you cannot do any analytics on the particular data if the data is not cleaned, right? So as a data engineer, we have to ensure that the data is clean. It's more quality, and also it should have some uh, business conditions applied. Like for example, like each customer should be feeding their social security number to us, like which is nothing but your Aadhaar card number. Like it's a unique number that identifies the customer. So we should have some primary key fields that identify each customer, and then our systems could able to find them out easily when we try to apply much more transformations on the data, right? So ensuring the data quality is one important key feature. And as a data engineer, we also have to build and manage the data pipelines. So what exactly a data pipeline mean? So pipeline is nothing but like um, uh, you are extracting the data from sources. There are multiple sources, and then you can also ask me why there are multiple sources. So in real time, as I said, for a particular throughout my session today, like I'll be talking more about the insurance or banking sector, especially insurance, because considering my experience in that particular sector. So consider, why do we have multiple sources? Because we have the data is coming from different systems. Like I have a claims system. All if some of the customers who met with an accident or who there was some damage for their vehicle, and they will raise a claim, and those all those claim requests, like they have a mobile app in which they will enter all the details, the date when the accident has happened, what vehicle was damaged, what is the location of the particular incident, everything. They will enter all the details and raise the claim request. That request actually came from a mobile application, right? Or it could be from a website, or it could be from directly from a like an office of our particular insurance company. So all these claim requests as a data, it comes and stored in our claim center application. So we have a claim center application. That particular database has all the data about the claims. That is one particular source. Similarly, all the new business quotes we get, all the customer quotes we get, that is in the quote system. So we have the billing system as well. That's a separate system. So we have data coming from different sources. And these sources, it could be flat files, it could be IBM DB2 or mainframes, or it could be Oracle, it could be anything, from any source. So what exactly we do is we will try to develop an application. That application can be developed using various pre-built tools. We have some ETL tools available in the market, like Informatica, Talend. We can also use the modern data warehouses like Snowflake, DBT, Databricks. These kind of tools, like which has the connectors to various sources. So you can actually make a connection established to that particular source database or a particular location if you're reading flat files, and you will read the data, and you'll write some piece of code in your application that actually clean the data, or and also transform the data into whatever the format that you want. Like for example, if the customer has entered his date of birth as November 28, 1985. So but you want the particular date to be in the format of YYYY/MM/DD. So the date, customer won't enter the date in that particular format, no matter what format he enters. But if your application is expecting the date to be in specific format, that is the kind of transformation code that you will write in your application. When I say transformation is nothing but a piece of logic that you apply on the data in order to uh, serve a certain purpose. So all the transformations you apply on the data, and then finally you'll store the result into a target database. So this flow is called as a data pipeline. So designing, building, and managing data pipelines is the major role of what a data engineer does inside the industries. It don't have to be insurance or banking or retail. It could be anything. So I'm saying it much more generic. My examples are more inclined towards insurance, but they're very, very generic. Okay. And the data that is stored inside the target systems, we are majorly being used by analysts, are majorly used by data scientists, and also by our business users. So yeah, I can talk more about how analysts will use this. So analysts can use this data to come up with, to identify the scenarios, like as one of the example I mentioned, identify the quotes that are not sold, identify the claims that has more than $10,000 per month. Claims of $10,000 in the last 1 month, right? So I want to identify if I have a requirement like that. The analysts actually try to do some more analytical operations on the particular data. So, and they use these target systems as the source. Similarly, data scientists, they will try to build the new models, such a way that they can actually build much more predictive models, consider this data as an input to train those models, and then come up with much more optimistic strategic business decisions that they can take in order to improve the business down the line, right? And our business users, who are nothing but our stakeholders, they actually try to use this particular data in order to generate the reports. We actually generate them the daily reports or the month-end reports or the quarterly reports. We also generate the regulation reports to the Fed or to the central government in India, whatever we used to call. But this reg reporting has to go out of these industries on a monthly basis just to maintain the the laws. So these are the main objectives of a data engineer. Whatever that I just explained, that is what exactly you can see here. So on a traditional ETL design, earlier in the I think I would say like till 2017 or 2018, we used a traditional ETL designing approaches where we used some tools like Informatica, Talent, and all that has connectors to various sources, extract the data, and the tool itself will provide some GUI based applications which will help us to clean the data and also transform the data. And finally we will store the data again into a certain target systems. Again, everything is tool oriented, and some coding is required, but we are more leaned onto the tool as well. So we have various sources, and we extract the data here, we develop the ETLs, and we finally store that into the either on premises data warehouses or into the databases that which we maintain for our reporting purposes. The major challenges that what we used to face for traditional ETL while designing the traditional ETLs are the data is siloed. When I say silos, is nothing but it's completely stored at multiple places. The data is there, it is available, but it is available at multiple places. So the connectivity is very less. We cannot take a common decision because we need to maintain a centralized data warehouse in order to take a collective decision on any business improvements. So when the data is siloed, it is very difficult, to take such decisions. And it is when the data grows, it will definitely face the scalability issues, because any application we develop, it will fail to address the performance when the data volume is higher. So if I build a solution, if my query is working fine on the data that is 1 terabyte size, but it fails to execute or compute the results in the expected time frame when it is dealing with the larger volume of data, then that's not the way how we should be dealing with ETL pipelines. So the solutions always has to be scalable, right? So that we used to have some traditional patterns, like while building the ETL, traditional ETLs, like we load the entire full load of data. Like every day we used to do truncate and load. So read the data from the source, store it into a table, and again on the next day, day 2, we will again load the entire data by truncating the existing data, and then we will load it again. So the truncate and load will take a lot of time. So that is which we call it as full load. It's a time-taking process. And then we have moved to incremental load. So on day 1, what happens is we will do the full load, but from day 2, we will get only the increments. I mean, like, for example, on day 1, we have a new customer who took the insurance policy from us, and his record will be stored in the database. But on day 2, let's say he changed his address. So rest of his details remains the same. So only his address has changed, right? So that is nothing but a modification of address. Only that particular insert or update record alone has to be updated into the database. Rest of the data should remain same. So that's called as incremental data. We call it as delta. So delta is nothing but only the changes. And then similarly, we have the slowly changing dimensions that comes over with the time as well. And we also have CDC. CDC is nothing but the same change data captures, but all the inserts, updates on the particular data record will be captured and then stored into the data lake. So what are the major challenges that which we used to have? We used to have, as I said, like we have scalability issues. It's difficult to deal with the volume. We also have difficulties to deal with the complexity of the code. Speed to access the data is also a big challenging thing. and maintaining the infrastructure on premises within your office, where maintaining those big servers to maintain the data, and you also need to hire some admins to manage the servers, and if whenever you need to update those servers, troubleshoot those issues, apply the patches for any security and maintenance upgrades. There are multiple challenges, right? Like, and you'll always see many outages. When I say outage, it's nothing but when you are trying to do a upgrade on a particular software on the server, then obviously what happens is, like, you cannot run those applications or your ETLs during that time. So there is an outage, and then due to that outage, all the depending applications are impacted. So you have to wait. So it's difficult, like, whenever there is an outage, and maintaining the infrastructure on premises is highly expensive, and the complexity is also very high with the maintenance, and also and also maintaining the labor as well. And during to do testing, it is an additional effort, because the data is in silos, and then integration between those systems is very, very challenging. How we have transformed into the modern data engineering. So in modern data engineering, like, either you use ETL or you use ELT. uh, you can use either approaches. I'm not saying that we have to use only ELT, no. So in my perspective, like, you can use any approach, ETL or ELT. ETL stands for extract, transform, and load. So you extract the data, store it into a particular data lake or a warehouse. You will transform the data, and then you load that into target system. But whereas in ELT, you will extract, you will load the data first into the warehouse, typically cloud data warehouse in the modern systems, and then you will transform it on the warehouse itself. So you can use either one of these approaches depending on your requirement. You don't have to use, because each organization has their own requirements. They have their own uh, business requirements. Data volume is different. The scalability challenges are also different. Or how, depending on those things, like, they don't have to, they can choose like either ETL or ELT, whatever it is. So we have designed that into multiple layers here. Like, we have ingestion layer, we have transformation layer, and we have a reporting layer. So usually ingestion layer is nothing but where we call it as a staging layer. That's another name for ingestion layer, like where you extract the data from various sources and you store that into a data lake. So data lake is the concept of maintaining the on-premises databases, where you will collect the data and store the data there. You will stage the entire data into the a local warehouse, which is on premises. But whereas the data warehouse is much more bigger. It's a collection of databases that which you can build on your premises. But the data warehouse has the ability to aggregate. You can actually build, aggregate, and also use the data for reporting purposes directly. The data in the data lake is not cleaned. You are just extracted and then storing it. That's called as data lake. It's cheaper to maintain in your premises, but it's not cleaned. It has all structured, unstructured, and semi-structured data. But warehouse is nothing but the same data. You are storing that into a relational model, where you have tables, you have relationship between those entities, and you can actually apply the aggregations. You can join those tables, and you can actually write the queries, and finally generate the business reports based out of the data warehouse. So maintaining a data warehouse is a little more complex, and it is more effort. So that's why we need the concept of separating both storage and compute in the real time. So we don't want we want data lake, and also we want the capabilities of data warehouse. So that concept is called as delta lake house. So which is nothing but that has the combination of both data lake and data warehouse. So uh, if you talking about that particular concept here, uh, ETL and ELT, which I have already covered, data warehouses, Delta Lake and Delta Lake House. So Delta Lake House is one of the modern, uh, data, the way how we design the data. And it's one of the modern data pipelining approach where we actually store the data into the lake house. And also we will try to, use that particular data, clean it, and then aggregate that and use it for various business reporting and analytics purposes. So in this particular journey, so while migrating from the traditional ETL pipeline design to the modern pipeline design, what we exactly have done is we have done initial assessment, like where we have analyzed the existing pipelines, identified the dependencies, what sources we have, what targets the data should go into, and we also have seen the complexity in building those applications. Should we lift and shift, or should we have to build the new application altogether in the new systems? Those kind of complexity analysis we will do. We will also ensure that do we have a team ready with all the skills that is required, and what is the cost comparison, is this project really worth enough to migrate into the cloud data warehouse? Because sometimes, if you don't calculate properly, the cloud data warehouses also is expensive. Like for example, like Snowflake, it says that pay as per usage, but still when you try to use such tools, you will end up with the higher cost if you don't keep track of how many queries that your team is running per day, or per week, because you will end up using all the credits, and then you'll end up paying more. So you have to pick these particular required tech stack for your project, based on the requirement, based on your project scalability, right? So you have to do the cost analysis as well. And once everything is done, you can actually set up the cloud infrastructure, choose the modern tools, whatever that is suitable for your design, and then start developing the application. Make sure, we also need to be very familiar with some the designing patterns, what standards need to be followed. That all needs to be set up while even before you start the application. We also need to be familiar with designing the CI/CD. You should be familiar with Git, which is nothing but the version control. And you also need to be familiar with various orchestration tools. So, this is a simple slide that explains about the transformation between the more traditional and modern ETL journey. Skills that really matters most for you guys, or for anyone, is I just try to list it very high level. Please do not assume that these skills are good enough to excel in the career. No, it's not like that. These are essential, but I'm telling you, the field of data engineering is a ocean. Every field has its own challenges. Data engineering, because every day you see a new tool gets evolved in the market. So, and you don't have time to learn or upskill everything, but you should keep an eye what alternative tool is available in the market, and then why is it worth looking into that or using that into your project. So but the basic underlying fundamentals that which we should be familiar will never change. So I always suggest someone to be much more familiar with the cloud concepts. You pick any cloud, AWS or Azure or GCP, it doesn't matter. You have to be familiar with all the foundational concepts for that particular cloud. You should be familiar with SQL. You should be familiar with at least one programming language, either Python or Java. shell scripting. Please make sure that you are good in understanding the concepts of data warehousing and data modeling. Like if I so I'll tell you, in the modern data engineering interviews at Netflix or Facebook or Microsoft or Google, it's very very common. The questions, like the kind of questions that which are being asked is, they'll give you a scenario. Like, for example, hey, if I ask you to design a pizza delivery application, um, how do you model that particular application? This is the kind of question that they will ask, and you will end up designing that system in front of them. They will give you 45 minutes to 1 hour time, and where you will end up designing the system. How do you design? It's not, you're not going to write a program there, but on a piece of paper, or on a canvas, you are going to draw what tables, potential tables that you might need in building that particular application. I'm sorry. Yeah, sorry. So you have to design that that particular data model there. So what tables is required, what relationships are has to be created between those entities, what primary keys and foreign keys has to be created. Because if at the end of the day, when a particular if you want to write a query, if you want to design an application, how the data model should look like, what are the attributes should be defined in the particular each model. Those are all those things has to be like, you have to think through them and then design that everything in that particular 1 hour of time. So the foundations, all these foundations and the knowledge comes from the academic level itself. So you need to be familiar with the concepts of OLAP, OLTP in designing the warehouses. Like you should be familiar with the normalizations. You should be familiar with the way how the data modeling can be done on a particular database. All those things. And then we have some modern cloud data warehouses, like where we use. So these days, what happens is we extract the data from various sources. We load that into the cloud data warehouse directly, instead of maintaining our on-premises data lake or data warehouses. We have switched ourselves to modern data warehouses, something like Snowflake, Redshift, or Databricks. So we are using Snowflake in our project, in our previous project, and also currently we used a Databricks as well in the past. So these Snowflake is a tool that which you might have heard of. Like, this is a tool that is that will give us the ability to load the data. I mean, you can stage the data from various sources, and you can build the data model in there itself, like in the transformation layer. You can write the SQL code, and then you can create an additional layer, like, all the transformed data will be stored into the analytics layer or the reporting layer, which can be directly connected to the data visualization tools like Power BI or Sigma or any other reporting tools. So and for data transformation, you can write your own Spark code, or you can use a data build tool. You can also use Databricks and notebooks. These are the various tools that which other industries are being used, widely using these days. And workflow orchestration, I would like to talk more about this particular thing. Why do you need to orchestrate your pipelines? You need to schedule your jobs, right? You write a piece of code, and you don't run that manually. You need to schedule that. You expect that particular code runs on every day. Like, for example, you have for a banking use case, you sent some money to you want to send 10,000 rupees to your friend. So you have done a NEFT transfer. Okay, it's not IMPS, it's NEFT transfer. So what happens? You expect that particular user to receive the cash after 24 hours. Why 24 hours? Because the bank has an application, that's a job, that runs on a scheduled time. Let's say for on everyday morning around 8 o'clock, banks has a batch process that runs its jobs. Those jobs actually run a piece of code which will execute all the pending transactions, and like try to credit that money into the end users. So that is the reason like why you have to wait for the 24 hours. But whereas you are actually, if you use IMPS, you can expect the end user will get money immediately, but for a charge, like you will end up paying another 2.5 rupees or 5 rupees, because there are these are the incremental jobs. Because as I said, like there is a delta, or a CDC, because of whenever there is a requirement, there is another piece of job that runs for every minute. So we call it as a streaming applications. So for example, when you guys like to watch the cricket, right? So when uh, when a particular batsman score runs for each ball, so what happens is the analytics also gets changed. So the win rate, the economy rate of the bowler, the run rate of the match, everything gets changed by ball to ball. So how does it works? So when uh, when a particular batsman score a 4 or a 6, and then immediately the next ball, automatically the required run rate or the economy rate of the bowler, everything gets changed, right? That kind of live data transmission comes through streaming applications. And those, for streaming applications, we always use messaging queues like Kafka, and other competitive tools. We extract the streaming data, process that, and then immediately reflect the results back. And streaming applications are widely used in sports, share markets. You see, like there are wide range of examples that which we can talk about, right? And data visualization tools, this is nothing but the final layer, where the data that which you transformed and stored into the target system, that particular data is actually visualized as a pie chart or a bar graph, or like or a tabular format, or whatever the much more uh, trendy way, like in how the business end user understands, right? So if you want to say that, sir, we have actually our sales got dropped by 2.9% in the last quarter. So one of our analysts want to convey this information to my CEO. How can he convey? He cannot just go with a sheet with all the numbers and all. He has to present in a tabular format or a diagrammatical format, right? That's why we use the data visualization tools. So, considering all the information that I have shared so far, like let me try to show you some of the sample ETLs that which we designed at our workplace. So, at one of our previous workplace, we have data from coming from, it's an insurance company, where the data is coming from the claim center, billing system, code systems and all. We also have some legacy systems and also some files. We all the data that is stored are coming from multiple systems. We actually stored that into the IBM. Sorry, there was a typo here. It's actually IBM Hadoop servers. So we used to have those IBM Hadoop servers, where which is considered as a data lake. We store the data there. The data volume is higher. That's the reason we used a data lake, because it is easy and cheap to maintain the data there. But the data is not cleaned. It has semi-structured and unstructured data as well. So we get the data in JSON files, we get the data in flat files, text files. We also get the data like in as a tables from relational database systems. So we have the data in this data lake. And what we used to do is this particular data, where we developed a Spark application. You guys might be familiar with Spark, so which is a distributed processing application. So it actually apply the transformations on the data, and then get it applied or executed on a distributed computing environment. So if you want to apply a small piece of logic on a data, but the data size is too big, okay, so you cannot run that particular code on that particular volume of data on a single system. So you have to apply the same logic on distributed systems. Like you have to divide that into multiple systems, apply the logic, and then parallelly compute all across the environment, and then finally store the results. So we use Spark for that. Spark is a highly demandable skill. So you guys can focus on that. So, and the final results, like we used to send that to the Kafka topics. So Kafka topic is a messaging queue. It consumes all the data as we process it, and then immediately we store the final result data into the Elasticsearch for faster indexing and faster policy search. Or we also actually store, one of our target systems is Graph. So we used Graph at our previous workplace as the target system because it is easy to represent the data. So basically, the Graph is much more clear for I mean, like it depends on the industry, like it depends on the organization. Some people use a different target system, like they can use just Snowflake, they can use um, different database, right? Like they can use Cognos database from Azure, they can use DynamoDB. There are different databases that which we have available in the market, but we ended up using Cassandra Graph. Apache Cassandra is one of the database, one of the NoSQL databases. There are a wide range of databases which you guys should be familiar with. We have SQL databases, we have NoSQL databases. We also have document-oriented databases like MongoDB, right? So all these databases store data, but the way how they store the data is different. In a relational database systems, which is SQL databases like Oracle or MySQL or SQL Server, you have data stored in tables, right? But whereas in NoSQL databases, like for example Cassandra, yes, you have the data stored in tables, but it is slightly different. And at the same time, the way how you store the data in MongoDB is in terms of JSON documents. So you might be familiar with the text document. You are familiar with Parquet files, or like you have JSON or XML. So JSON and XML are semi-structured, right? So storing the MongoDB stores everything in JSON files, okay? And the Graph, what it does is, like, it stores, it don't have tables, it has vertices and edges. So if you see here the vertex, here all these circles are nothing but the vertexes, and the lines drawn in between them is nothing but the connection between those vertices. Like for example, you take policy vertex. What does it contain? The policy vertex contains policies of that particular insurance company, right? And we have a person. So what are the attributes of a person here? First name, last name, date of birth, age, address, phone number. All these are attributes of this particular person vertex. So what is the relationship between the policy and person? Each person has a policy, right? And there is a, so if I want to query on this particular graph database, like I know the person name, like identify all the policies, um, or identify the person with a policy number XYZ123. Like if I give a policy number, I want to know which person has that policy and what vehicles he has, in what address he resides, and all those details. I can easily get that from this particular design. So I designed my graph database in such a way that, here again I am applying the concepts of data modeling here, right? So I have designed this graph database system with a lot of vertices and edges, such that if I have, it will serve any use case or any query that I need at the end of the day. Like, for example, if I want to identify all the policies that are due for renewal next month, if this is my question, I can actually write the particular query on this particular graph database. But the way how you write the query on a SQL database is like basically looks like select star from so and so, right? You usually write those select statements, insert statements, because that is all traditional RDBMS. But whereas the graph databases, they have their own. Like if you want to query a MongoDB to query a JSON document, your query looks different. The syntax looks different. Even similarly, to query the Cassandra graph, your syntax looks completely different. So you use a graph g dot v, like g is nothing but graph instance, v is nothing but vertex, and you will specify these properties. The syntax to query these databases are completely different. So when you are trying to learn, as I said, like you should be familiar with cloud, you should be familiar with SQL, you should be familiar with um, orchestration tools and all those things. I also suggest you to be familiar with any one of the NoSQL databases or graph databases as well, right? So this is another project example which I would like to talk today. This is my current project, I would say. So where so we have data coming from multiple sources here on the left hand side, and all this data that we are extracting that and then storing that into our Snowflake. So you see this entire middle layer. So this entire middle layer, this big one is nothing but the Snowflake. We are using cloud data warehouse. So this is a perfect example for ELT. It's not ETL. So the previous example is ETL. Here we are extracting it, we are transforming it using Spark, and we are finally loading that into the target systems like Graph or Elasticsearch. This is a perfect example for ELT, where we extract the data and we load that first into the Snowflake data warehouse. It's a cloud data warehouse. So first we will load that into the raw layer, and then we will design certain models. Like, because the data is coming from multiple places, but we need to segregate that. We need to store only the policies alone into a separate system, the codes alone into a separate system, claims alone into a separate system, right? We need to model that, design that, and then prepare that intermediate layer. So that is where, like, we have created this intermediate layer, and finally the transformations we will apply, and then we will store the transformed data or the cleaned data into the analytics layer. And from the analytics layer, we have connected our end user reporting applications like Sigma, or we can use Power BI, where we will generate the reports on a daily basis, on a monthly basis, and quarterly basis as well. So this is another example how you can the modern ELT pipeline is designed in one of our previous projects. So similarly, like, if you are using AWS, this particular diagram explains one more flow. But like, instead of using Snowflake data warehouse, so we are using Amazon Redshift data warehouse here. So where we have the same landing zone, we have analytics layer here, and intermediate layer and analytics layer. So when we say user friendly, that's nothing but the final analytics layer. And Amazon QuickSight is nothing but their data visualization tool. Just like similarly, we are using Sigma here or Power BI. So here, like inside Amazon cloud, they have like QuickSight, which is another data visualization tool. So at the end of the day, the pipeline design is same, but the tools that what we use to design that pipeline will vary according to what you use in your project. Some people use Amazon, some people use GCP, some people use Azure, some people end up with Databricks and Snowflake itself. Whatever, even Databricks and Snowflake underlying, they actually use any one of these cloud data warehouses, right? So I will try to wind up here. since we are almost the time, but I would like to take any questions if you guys have. I know I tried to cover a lot of concepts here, like in the stipulated amount of time provided, but I'm going at my own pace. But I would highly suggest you guys to go through the recording again, take a pause at wherever you want, and then make sure, But feel free to reach out to me for if there are any questions. I'm happy to help. My main intention is to show you how the ETL pipelines are designed, what tools they use, we use in the industry, what skills that you guys definitely require to upskill, those kind of things. What exactly we do with the data, how and where we use that particular cleaned data, how it is useful for to run our business. These are the kind of questions that which I always have in my mind, and I want to give more clarity on those concepts to you guys. So if you guys have any questions, I have another 5 minutes time. Please feel free to ask. And even after the session, you can always drop me an email. I'll share my email ID to Uday Shankar sir, and you guys can reach out to me at any time. Any questions?
So good morning, sir.
Mm-hmm.
Sir, so you have over 14 plus years of experience in this data engineering, right?
Mm-hmm.
So how is it compared to the previous AI era, before 5 years? How this data engineering role was handled, and how after AI it has progressed? It is progress.
Nothing much change. To be frank, we get more time, we get more help because all the tools that we use, like for example, Snowflake, Databricks, DBT, even the traditional tools like Microsoft Visual Studio Code, VS Code. Any IDEs you use, any tools that you use, it's all AI chatbots are available now. They are integrated with chatbots. Like for example,
Agents.
yeah, not agents. Agents are different. So agents are different. These tools are integrated with a chatbot on the side. For example, let's say like you guys are familiar with Eclipse and IntelliJ IDEs,
Yes, sir.
right? So you open the IDE and you develop a project. Okay, that's how it used to be. Imagine now you have a plugin that provides Microsoft Copilot support or ChatGPT support to that particular IDE. And then on your right hand side of the screen, there is a chat window, right? So where you can ask a question. uh, like in your project, you can open a particular code, and then parallelly, if you ask a question, hey, uh, can you please change this piece of logic to address this particular, so you ask some question with a prompt, and then it automatically read your code and then fix the things of that particular project there itself. So you get more assistance from AI now,
Yes,
because
sir.
your co-pilot or your chat gpt is integrated or built with these development interfaces itself, or the tools that whatever we use at work. So the life of a developer has become easy. AI is not actually replacing, it is actually trying to make our job better, much more simple and better. So we are trying to um, transform ourselves. We are trying to transform what I would say. Uh, we are trying to transform to use AI in every requirement we work on every day. So earlier it is like no dependency. Now we are actually taking the help of AI and trying to, you know, um, build the solutions much faster.
But sir, when you use AI for coding, but the code which the AI provides may not be always secure, right? So you need some human to check the code
Correct.
if it is secure or not.
Correct. So it's not, we don't call it as secured. It's not reliable. So it's not about security, it's about reliability. So it all depends upon how good is your prompt. So you have a requirement, you ask a question to the AI with a prompt, and it will try to give you an answer back. But it will try to give you an answer based on what is available on the internet, right? So it is definitely, you need to have those foundational skills to review and analyze the response that is coming from AI, fine tune it, use it accordingly to your particular requirement. I don't suggest you to blindly copy and use it, because that is not 100% correct or reliable. But you need to have your own due diligence, um, review the code, and then tune it and then use it accordingly, like in your as per your requirement. So you can think that, like, hey, AI has is there with me and then I can do anything. No, you you still should have your own skills. You can use AI as a helper, okay, to do the
Okay,
things
sir.
faster, but
Okay.
you cannot completely rely on it and then just screw the things out. Got it?
Understood.
Next question.
Sir, good morning, sir.
Mhm.
Sir, what would be the programming language we should be thorough for the basic data engineering entry level?
Programming languages, see, I would highly suggest Java and Python are widely being used. Python is everywhere.
Yes, sir.
See, every associate, every student, you should be familiar with few things no matter what. Okay, you should be familiar with at least one programming language, one scripting, one like definitely SQL, like database concepts, and also the SQL itself. And you should be familiar with one cloud language. You should be at least familiar with one of these. Uh, these are very basic essentials, I would say. They're basic. Without that, and on the top of that, you should upscale on multiple tools, that whatever that we talked about in this meeting. Like, if you are familiar with Databricks or Snowflake or DBT, or or any other data visualization tools, that all helps. Like, I highly suggest, when you guys do any projects, use one of these tools. Like, okay, even in your like, you can consider a use case on your own. Try to get data from multiple sources. Try to build a ETL pipeline on your own by using any of these tools. Each of those tools actually provide 1 month or 1 year free licenses, or like, I mean, like, free memberships, where you can actually try out your projects. You can actually build. They're very interesting too.
Sure, sir.
Mhm.
Sir, like how AI automation is helping in building smarter data pipelines? Like automation is also there here.
No, you have to in a it won't build the entire pipeline for you, but it will give you a plan on what based on the information that is available in the web, right?
Yes, sir.
It cannot build the entire pipeline for you. You can tell that, like, hey, can you write a piece of code to extract the data from this source? Fine, but that code is only a template. But you have various sources. The connection parameters to connect to each source will vary. You need to pass your secured connection fields there, the port number, the database details, the environments, everything. It is like, completely your organization specific, right? You also need to get authenticated before connecting to any system. You need to provide your private key or RSS. All those things you have to do. The AI will try to give you a template, or it will try to give you a sample piece of code. It will try to give you a high level approach or a plan. But you have to do your work as well. No, it will just help you, as I said.
Yes, sir. Thank you, sir.
Sir, is there any agentic frameworks used for this process? Like
No,
Agno, Strands, something like that.
we didn't use any agents in our projects, uh, but there might be other clients who are interested in using them. AI agents are the upcoming and evolving concepts. They are being developed. They are yet to be used across the industries. So they might be used down the line, especially, like, because all companies, like, especially even in US, yes, we are using AI. only to certain extent, right? um, I mean, we are just still doing the same work what we used to do earlier. We have the help of ChatGPT or Claude. I highly suggest, if whoever is using AI, try to install Claude, Claude. It's from Anthropic, on your mobiles, because Claude is very, very good for programmatic prompts. It does much better than ChatGPT. Is much better than, in my personal opinion, Claude is very good for programming. The ChatGPT is good for general, prompts and all, but in my opinion, Claude is very good. So we use these AIs. We ask prompts. We used to get some help and all, like, or we used to clean our code. We used to test our code, whatever it is. But we are not using any AI agents. We are developing our applications on our own. But still, all industries are doing the same, but they're not completely transformed to AI and all. No one is going to uh, uh, you know uh, remove the leg of the chair that which they are sitting until and unless, who knows, because I cannot say, hey, let's use AI agent, and then which does all this job, and we don't need these three associates in my team. Like, it's not like that, right? Because one thing is, it is not reliable. It is, of course, a management decision. They are doing some research. They are trying to develop some agents, not in our organization, maybe at other places, because that is a lot of funding is required for that. It's a research
Yes, sir.
area.
Of course, like it is not completely reliable, but like with that help of like there is a thing called MCP, Model Context Protocol. So
Correct.
with that, the work of data engineering is can get much more easier, right? So,
Right. See, the manual effort will be reduced, right? These agents will do the whatever that which we are currently doing, uh, but not 100% accurately. That's for sure. So instead of 4 data engineers, maybe 1 or 2 data engineers can be cut down when we try to replace the workload with AI agents. But this concept is a research and evolving topic, which is yet to be used by organizations, and they will use it. They will use it because they want to cut down the costs down the line. They'll definitely use it. But as a engineer, what I highly suggest is, that's where the whole conversation I'm trying to make here is, you have to be very strong with your foundational skills, because you have to prove, always you have to prove that AI does something wrong. It is not 100% reliable, and this is the place where human intervention is required, and our skills matters most, right? So that is where we have to show our presence as well, right? We need to be skillful. At the same time, we also have to uh, walk through the journey along with AI.
yes, sir.
Okay, you understand, right? We should not,
Yes, sir. I
uh,
understand.
don't afraid too much of AI. I would say, like, be confident, grow yourself with your skills, and try to work with AI.
Can
You
use it as a
cannot survive
leverage.
alone. Yeah, I don't say, like, you cannot survive alone in this modern competitive world. You have to work with them together, so that, like, the decisions, the applications you develop will be much more quick,
Yes, sir.
much more effective. Yeah,
Thank you, sir.
the effectiveness comes from your experience and your skills. The quickness comes from, the code that it generates from its LLM models. I know it's quite a buzz going on around the world, like, about the AI, especially last 1 year. Don't afraid too much. Always I'm telling you, the foundations are very, very key. Wherever you go, that's what I learned. Uh, the more strong you are on the foundational concepts, data warehouses, data model, SQL, all these foundational concepts, Python, everything, they always matters, because even a new tool gets evolved in the market to address some existing challenges, but those new tools are also built based on the foundational concepts only. There is something wrong with the process, and they try to improve that.
Got it.
Mhm. Next question.
I think no more questions. Dharni, madam.
Yes, sir.
Yes, madam.
Okay.
Thank you, Srikanth, for your great session today. Madam will propose the vote of thanks. Yes.
Thank you so much, sir. It's my privilege to deliver the vote of thanks here on behalf of RMK College of Engineering and Technology for giving us the enlightening session for our generic talk series on modern data engineering, trends, technologies, and principles. First and foremost, I would like to express my heartfelt thanks to our esteemed speaker, Mr. Srikanth Gorripati, Senior Data Engineer at Mutual of Enumclaw, Fortville, Indiana, USA, for sharing his valuable insights and experiences. Sir, your session was truly broadened our understanding on how modern data engineering works and its real world application. And we also sincerely like to express our sincere gratitude to our chairman, vice chairman, advisors, principal, and our deans for their constant support and encouragement and guidance in organizing such knowledge enriching session. We also like to extend our appreciation to all the participants and the students who joined us here and through the YouTube live stream for making this session a success. Once again, thank you all for being a part of today's event. Thank you, sir.
Thank you so much. It's been a while. Let me know once the YouTube streaming is done so that I can talk for a few minutes.
Yes, sir. I'll be ending up the session now. Just a minute.